All right. It is week 4 of CIT 225. It's me and Pablo here. Y'all aren't cool enough to be here, and that's cool. Maybe next week some people will join us. Today we're talking about joints. Let me get this a little down further. Oops. Okay. I usually see I'm technically supposed to wear a tie when I'm teaching classes, so I keep the camera so they can't tell whether I'm wearing one or not. So today we're talking about joints, which is one of my favorite topics. I love joints. Joints are super fun. You still hear me? Okay, good. So I'm gonna go ahead and share my screen here, and we're gonna go ahead and I'm gonna show you some stuff here. Okay. So, all right. So here, I've got this. So joining tables is, and that joke you told earlier was apropos for today, Pablo. So the thing about joining tables, so when we create tables and we create the relationship between them, and we're gonna talk about this in a minute when we start designing a database together. Tables should only have the information that is denoted in the title of the table. You shouldn't have anything superfluous and nothing that doesn't belong there, right? It has to do with the table, which means in a relationship database model, you're going to have multiple tables. So you'll have, and so to get this information out of the tables and onto the screen for your customers, you have to join these tables. And there are 4 kinds of joins. Okay. Well, there's also what they call a what is it called? The name escapes me because I don't use it. It's a Cartesian join. It's not called Cartesian join. It's I forget, it'll come to me in a minute. But there are other types of joins, but these are the 4 ones you need to worry about. This one actually doesn't exist in MySQL. Okay, so here we got 2. So if you remember Venn diagrams, I've got 2 circles, and I got circle A and I got circle B, and then where they intersect is where the 2 circles contain the same values. Okay, so now, and I'm going to show you these in code here in a second. If we do an inner join, the results that will return are only things that exist in this green part here, where it overlaps, where it's the same in both tables. If I do an outer join, okay, an outer join means I'm going to return everything that's in the full circle and only the things in the yellow circle that match in here. Okay, and I'm going to show you that in a second. So that's what an outer join is. So the outer join is I take everything in the one circle and only where it overlaps. So I'm going to take all of this here, right? So there's left outer join and right outer join. A left outer join is literally the table on the left. So if I do a left outer join, it's everything that's in the yellow circle and what matches in the green. If I do a right outer join, it's everything that's in the blue circle and what's matching in the green. If I do a full join, which does not exist in MySQL, but I'll show you what the results look like. It returns everything here, okay? So that's just a really high level what joins do. Until you see the code run, it's hard to understand. So I'm going to jump into the code now, unless you have any questions, Pablo.
No. It's all right.
Okay, so here's the code to do this with. This is the wrong code. This is the code from last week. Don't save. Open. Bring me week 4, please. MySQL examples. BYU. Oh. All files. Yep. There we are, and there's week 4. Don't save. Oh shoot. Okay, 1 second. Let me pause my screen share for a second because my computer is being wonky. Open. Where? Okay. And then let's close this out here. Let me resume my share. All right. Minimize that. Okay. And let me go ahead and connect this to a database. Okay. All right. So give me my guys here. Okay. And I'll go here. Okay, so the first thing I'm going to talk about here is this command union. Okay. So what union does, it takes all the results from the first query and joins it with all the results from the second query. Okay. The only thing that has to match are the number of columns in the select query. So here I've got select first name and last name from actor. Use Sakilla. Select first name, last name for actor. I get that. I get first name, last name from customer. I get that. So two separate things, right? If I put them together like this, it just gives me the combined results. It's up here. Okay. So here I had 201. Here I had 599. So now I've got, you'll notice the numbers don't add up. So here this is 700 and.
There is something that you are not sharing.
I'm not sharing? Oh. That's, am I sharing now?
No, you are just the Venn diagram.
Oh, that shouldn't be. Oh, I see what I did. Oh, I know what I did. Hang on a second. Hang on a second. Let me stop my share altogether. I shared the application and not the entire screen. There we are. Okay, so that goes away. Okay, you see it now?
Yep.
Okay, so sorry about that. So here, if I do select first name and last name for actor and I run that, I get my results here. I get 201 was returned. I do select first name and last name from actor. I run this. I get 599 rows returned. So the two of them together are 801. So 201 plus 599 is 801. No, 800.
800.
800, right? Okay. So now if I union these together, I get 797 rows. So what happens is there's some rows missing. So what happens here, right, is when I use this union command, it returns all the values from here and all the values from here, but does not return anything that matches. So if the same name exists in both results, it's not going to return it. Unless I use this word here, union all. If I change that to union all, I get all the rows. Okay. So union takes the results from two queries and pumps them into one result. But like I said, all that matters is that the number of columns are the same. So I can do this and put store ID here, right? And if I run this, it runs just fine. But it gives me the store ID instead of anything else. Okay. So union is a fast and dirty way to get results together. Okay. And again, union versus union all. Union brings me everything except things that are exactly the same. Union all brings me everything, including the duplicates. Okay. Now, let's talk about joins here. That's a really big inner join. Okay, let's do this here. So let's say I want to do select. Give me this here. Let me take this query here. Okay. Bring this down here. So I'm going to do select first name, last name from customer, inner join actor. Okay. So here's the anatomy of a statement with a join. We still have our select statement. We still have our from statement, but I added this thing here. So what that is, it is an alias. So what happens is anytime I need to mention that something's from the customer table, I just have to use the letter C. I don't have to write the word customer out. And I'm interjoining the actor table, and I'm calling the actor table A. Now, the reason why this is important is because if you have column names that exist both in the customer table and the actor table, and you don't designate which one you want, okay, it's going to
Ambiguous answer.
it's gonna give you it's gonna say I forget the error should be something like vague column. So let's do this on a dot last name on last name a dot last name equals C dot last name. Okay, so if I run this, yeah, it's just saying they have an error in the statement. It's because yeah, there we are. Column first name in field list is ambiguous, so it doesn't know which one it's coming from. So we've got to put this designation here. If the column doesn't exist in both tables, you don't have to do that. But for the sake of sanity, you want to do it. Okay. So I'm gonna go here and I'll do a first name, a dot last name. Okay. So when I run this, let's do here too. Let's do so if I run this, okay, it just returns everything that's the same. So there are 44 rows that exist in both of them where the entries are the same, right? So if I do, so let me just take this out here. Okay. So if I do this, I just get the names that are the same. Okay. Let me take this now, bring it down here. And I'm going to change this to a left outer join. Okay. Now, and I'm going to change this to C. So what it's going to do, it's going to return everything from customer. And then only join, let me see this. We're going to run the results for this here. So you got all these who are in customer. Oh shoot. Yeah, that's what I want. So I'm just gonna do this last name here. So I'll just go back to his last name. That'll explain it gooder. Okay. So I do this here, I do this, I get 44 rows and the last names are all the same, right? I go here and I say, show me the last name of customer and the last name from actor, but I'm gonna do a left outer join. So I'm gonna return everything from the customer table, but only things that match from the actor table. Okay. So we look at these results. Now I'm getting every one from the C, but only where it matches the A. So I got all these nulls here, right? If I change this to a right outer join, it's going to be the exact opposite. Okay. So here are the names from the actor table, and here's where they match in the customer table. Make sense?
Yes.
Okay. So now full join doesn't exist, but if you want to see what a full join looks like, I think I should be able to do this. That's what a full header join looks like. It returns everything from the customer table and only the things that match in there, and then it just unions it all. So it just doubles out what you had here. Okay, that's what a full union does. Now there are reasons to do these queries. A lot of times, if you're comparing data from two different tables and you want to see where something's missing, you do that. And we'll go through when we do the case studies. We'll talk more about why we do left and right joins, and next week we'll talk about it a little bit more as well. But this is just a rough cut of how this works. Okay. Now look at this monster query that I have right here for you. This is a big join. Okay. So here, oh, I think this is the wrong week. Okay. I've got select last name, title, and rating from actor, and I'm joining it to film actor on actor ID, and I'm joining it to film on film ID. So what I want to know is the last name of the actor, the title of the movie, and the title of the rating of the movie. This information doesn't exist in one table. The actor's name exists in the actor's table. The film table is in the film. The film title is in the film table. If I look at what's in the film table, I don't have anything that connects me to the actor table. And if I look in the actors table, I don't have anything that connects me to the film table. Okay. And that's because I can't have a direct connection to them, because one actor can be in many films and many films can have the same actor. So these two tables have what's referred to as a many-to-many relationship. Okay. So I have to create a third table called film actor. And what's in the film actor table is 3 columns. The actor ID column, the film ID column, and the last time it was updated.
Brother Dan.
Yeah.
The way that I was doing it last semester on the introduction to SQL.
Yep.
I was creating an ERD, and then on the ERD, because it's visual, there are people who are visual.
Yep.
It was easier to comprehend
how
to join it.
Okay. And in a few minutes, we're gonna design a database together, and I'm gonna show you how to do that. I love the workbench here, because when you want to make a database, it's so easy. It's so easy. But I need to go how the code works. Okay. Yeah. So I've got it. So I have these two tables. So when I want to select from them, I've got to do 2 inner joins. The first, I'm going to join actor to film actor, because actor ID and actor ID is in both of them. And then I'm going to join film to that result, because film is in film actor. I'm going to join film to film actor, because film ID is in both. So what happens in the background when this runs, when you run this query, it pulls in both tables into active memory and then connects them through the column you tell to connect them through, right? So it's going to pull in all 3 tables, pull them into memory, and connect them through the columns you say. So when I run this, I'm going to get a result, and I have all of these. Okay. So that's how these joins work. They're linking the tables together. Now, if there are no questions, we're going to go into a database design, and that's going to allow us to see how this works for real. All right, so I am designing. Where am I? Where to go? There. Oh no, I lost it. Okay. I had it all set too. That makes me sad. Okay. I'm just going to create a new database. Okay, so I'm going to create a new model, and I'm going to create the diagram here. And I'm going to create a database that will track my favorite recipes. So I'm going to create a table. I'm going to call it recipe. Now, one of the key things to remember about tables is they are never plural. The name of the table is always singular. So recipe. Okay. The other thing to remember about tables is the first column will always be the ID column. Now, a quick note about data types. When you're looking at the data type for numbers, you have int, medium int, small int, and tiny int. And if memory serves, and I'm going to just go with me on this, the numbers aren't going to be exactly right, but I want you to give you an idea. So we've got tiny int. We have small int. We have int. And we have big int. Now, Pablo, what do you think the difference in these guys is?
I would guess that is the amount of memory that it will take, the bytes.
Right, exactly right. So what happens is tiny int, I believe I'm going from memory on this, so my numbers might be off, but this gives you the general idea. Tiny int is negative 254 to 254. Those are the only numbers that'll fit in there. Okay. Small int, I think, is somewhere around, let's just call it negative 65,000.
Yeah.
To positive 65,000. Integer is 2.1 million to 2.1 million positive. Okay. So you get the pattern here, right?
Yep.
Okay. So now, and big int, I think, is something like,
It's
some
extremely
ridiculous.
large.
It's like huge, like some like 60 billion.
Yeah,
Something huge.
65 billion, something like that. I read it
Yeah,
the other
it's exponentially bigger. It's not 65 million. It's like 65 billion or trillion or something like that. So
Yeah.
it's huge. Okay. Now the other difference here is this is 4 bits. This is 8 bits. This is 16 bits. And this is 32 bits. Which means for every row that has this column, it will take up at least that much space. Okay. Now, why is this important? When I worked for a company one time, and they had I started work for the company about 4 or 5 years after it opened. And the company was a company that did title searches for houses. Okay. And they got data from all over the country, and they had a bunch of databases for each state in the country, but they had one table for sales. And that sales table would track every search that someone did that ended in a result that they charged them for. You got me? You with me? So when they built out the table and they were coming with the ID number, they said to themselves, okay, what do I need here? And you'll notice by default, it's always int. By default, it's always int. So whoever designed the database just used int. And they thought, I don't know if they thought this, but they may have thought, wow, 2.1 million rows. It's going to be a long time before we see that. It was 4.5 years. So I started there just when it had reached like 1.8 million rows. So they were 300,000 rows away from maxing out. And when you reach that top number, you cannot add any more rows. So what they had to do was they had to update the table online and change int to big int. I think when we did, there were 1.9 million rows. So it had changed 1.9 million rows from int to big int. So how long do you think that took?
Probably a long time.
It took around 36 hours to do.
Wow.
Because what happened is it went to every row, to every space, and increased the size of that one because every row had to be touched.
Yeah.
It increased every row, every column to 32 from 16. And that also doubled the size of the table. So that table that was already something around, if I remember, like 400 some odd gigabytes for a table grew to just shy of a terabyte in 36 hours. So needless to say, it was not a good choice, right? So it's important when you design a database to choose the right data type. It's hypercritical. And I have a video somewhere in my YouTube playlist, and I spent about an hour talking about data types. I'm not going to do that tonight, although I could. Okay, so sidebar here. So now I've got these letters here. So PK is primary key, NN is not null, UQ is unique. I forget what these other ones are. So primary key means that this is the default index for the table. Okay, and because of the primary key, it can't be null. It's also by default unique, but it doesn't check that off. Okay. Next, we need a title for the recipe. Title. And then we have our varchar 45. Now, if you look at here, we've got varchar and we've got char. Where are we? Here. We got char and we got varchar. Any idea the difference between char and varchar?
Chart is a short test, and the bar chart is 45 to 55.
So with char, var and char and varchar, I can do char 45, and I can do varchar 45 or 54. So they can be the same thing, but there's one. The difference is these first three letters.
Oh, variable chart.
Right.
You can change them.
So right. So we're here. If I do char 54, every row, that column will be 54 bits long or 54 characters long, regardless if you put 1 or 30 in there. Varchar, it can be up to 54 characters long, but if you only put 2 in there, it's only going to charge you for 2.
Yeah, on the chart, if you put less than 54, it's gonna give you like an error, right? Isn't it?
No. If you do char 54 and you put in anywhere from 1 to 54 characters, it'll be fine. But the thing is, so when you go to the post office, right? And the UPS does this. So they take the measurements of the box, right? And depending on the size of the box, UPS will charge you for what they think could ship in it versus what actually ships in it on the weight, right? So if I brought in, like Amazon will give you like a 10 by 10 box for like a box of thumbtacks, right? And they can do this their own shipping. But if I did that box through UPS, they're going to charge me for what theoretically could fit into that box, right? That's what char is. Char is every column you create in this row is going to be 54 characters big, no matter how much you put in it. So it's always going to be this big. And that takes up a lot of space, right? With varchar, you can go up to 54 characters. So you put 3, it's only that big. 10, it's that big. So it's a variable size. The only time I'll use a char is like for a state or something that I know that is only going to be 2 or 3 letters, right? All right, so then we got that. So we'll have ingredients. Ingredients. All right. And then we'll have a cookbook, what book it's from. And then we'll have author of that cookbook. And then we'll have calories for that recipe. All right. Let's just stick for there, right? So now what happens when we design databases, we create that first table, and then we look at it saying, okay, does it make sense to have this column in this table? So let's look first at the cookbook. Okay. So if we have the cookbook choice here, that would mean this recipe only appears in one cookbook. And that's probably not right. So we really can't have cookbooks. So what'll happen a lot of times when people who are making databases and they're new at it, they'll do cookbook 1, cookbook 2, cookbook 3, right? And the problem with this is, A, we don't know how many cookbooks there are going to be. And B, this is not normalized because we have redundant data. Okay, we don't want this. We want the data to make sense. If the value is not unique to the table, it should not be there. So cookbook should not be there. So I'm going to remove it. Okay, so now what I'm going to do is I'm going to create a cookbook table. All right. Here's my cookbook table. Cookbook. All right, and here I'll have cookbook ID. I'm gonna leave these default because so I have the title. I have author. I'll have cuisine, the type of cuisine it is. Okay. Now, since author is here, it doesn't need to be here, right? So I don't need that. So I can go ahead and remove author from here because author's attached to the cookbook, not to the recipe. So I'm gonna go ahead and remove author from recipe. Delete. All right. Now, let's look at cookbook for a second. We want to connect cookbook to recipe because one cookbook will have many recipes and many recipes will be in the one cookbook. So over here, I've got this, this many-to-many relationship here. So what I'm going to do is I'm going to take that and I'm going to do this and create that table. So let's just do it this way because then the words will make sense. Boom. No, you go away too. I want you to go away. Thank you. Okay, you go here. So we'll go here and let's do this and that. So now cookbook has recipe. So the only two things here are the cookbook ID and the recipe ID. Now, if you look at this table, and you'll notice that these two columns are the primary key. And that is completely okay as long as these two values never repeat. If they repeat, you've got to change it. Okay, now keep going. I've got the author here. So let's go to the author for a second. The author, could a cookbook have more than one author?
Yes.
Yeah. So I can't put author here because that's many to many. So I'll take author out. And I'll make an author table. Okay. And I'll make an author table. Author table. And it's author. And we'll do author ID. And then we'll do last name. And then we'll do first name. All right. Now, since it's many to many, we're going to grab our many to many and do cookbook has author. And again, as long as these two values remain unique, you don't need another column in there. Okay. Now, cuisine. One cookbook, let's just say, for sake of argument, this is incorrect. Let's say, for sake of argument, a cookbook only has one cuisine. It's either like a Mexican cookbook or a British cookbook or a French. There's only one cuisine in it, right? Do I want to keep this here like this? And cuisine. We could. And what'll happen is each time something's in here, we have to type in the cuisine, right? Now, keep in mind, when we're looking at something like this, we want to make sure that we, for lack of a better phrase, idiot-proof our database. I don't know about y'all. I'm a horrible typist, as witnessed when I was typing the code. And if I'm entering things into this database and I'm trying to type French, let's see, how many times can I type the word French right? See, already once I would see. Okay, so just typing it 4 times, I got it right once. So if I'm entering stuff into a database, I want to make sure it's written the right way all the time. So what I'm going to do is I'm going to create a cuisine table. And the reason I'm going to create a cuisine table is because when I do my front end application and someone's inputting a new recipe, I'm going to have a drop down list on what cuisines are available. And so that drop down list is going to be populated from this table. So we're going to make sure that no one types anything in wrong. And it's going to be the same every time. And now I'm going to create a foreign key. It's a one-to-many. I did that wrong. I did it backwards. Delete. I got to get the cuisine column out of here. Delete. And now I do this. Boom, boom. All right, so now the cookbook has a cuisine. And what this does, so now what a foreign key does, it makes sure that nothing can go in here that doesn't exist in here. So if in here you've got French and Italian and Vietnamese and Japanese and Indian, but you don't have Mongolian, and you try to input Mongolian into here, it's not going to work. Also, it means you can't delete from here while something is still in here. So if you try to delete Italian cuisine and there's Italian cookbook, then you can't. Also, you can now tell what cuisine the recipe is from because you've got a direct connection to it. So you can write a query, show me all my Italian recipes, and you can pull them out. So let's go to the ingredients. Obviously, a recipe has more than one ingredient, right? So we're going to need an ingredient table. Ingredients. That's close enough. Have the ingredient ID, and we have the ingredients. And I'm going to do something here.
I'll watch the video tomorrow.
You watch the video? You're going to check out?
Yeah, I'm
okay. I will finish this solo.
Please.
Okay, Miss Pablo. I'll see you later. Have a good week.
Bye.
Okay. So I'm flying solo here, which is totally fine. So here, I have the ingredients. Okay. Now what I'm going to do here is I'm going to add calories here. Actually, I'm not going to do here. So, okay, so I'm going to do calories per serving here. Okay. And I'm going to make this a small int because I'm going to make this a tiny int because anything over 245 calories probably shouldn't be in here. Okay. All right. Now, I can't directly link this to here yet because I don't have the measurements. So I'm going to have to create a measurements table. So here I'm going to create a measurement table. Okay. And measurement ID, and I'll have the measurement. Okay. All right, so now I'm going to create a many-to-many join on this, okay? I'm going to create recipe has ingredients, okay? And I'm going to say recipe ingredient has measurements. Actually, I'm going to do that. I'm going to do this, but I'm also going to do this. I'm going to do this here, okay? So I got the measurement ID, right? I've got the recipe ID, the ingredient ID, and the measurement ID. But also here I need to add a column. I'm going to call it measurement amount. Okay. And these are all going to be, that's going to stay in, that'll stay in, this is going to be tiny int. Okay. So now here, and my spelling is horrible and I apologize for that. Okay. So now in this table, I'm going to have the recipe ID, the ingredient, the measurement that it's using, and the amount of measured amount. So in measurement, it'll be like cup, spoon, teaspoon, whatever, tablespoon. And then measurement amount will be like 1, 2, 1.5, whatever it's going to be. So in here, I could have 1.5 teaspoons of baking soda. 1.5 would be here, teaspoons would be here, baking soda would be here, and to that recipe. Okay. Hopefully, that's really bad spelling. Ingredient. I wish there was spell check here, but there's not. Okay, so that's my spelling is horrible, so I apologize. All right, so here. Now, the other thing I'm going to put here is I'm going to put the calories. I'm going to take calories out of here because that doesn't make sense because it might be different based on size. So I'm going to put the calories here. Okay. And then I'm going to put here, I'm going to put tiny int again. Okay. Now what this means is, and this is where I'm going to take calories out of this one here. Okay. And why I'm doing that, and I'm going to take ingredient out of here. Ingredients belong there anymore. Okay. Okay. Now the reason why I put calories here as opposed to in the recipe table is because now I have what's called a computed column. So I can run a query and just take the sum of the calories in here and then give it to the result of the recipe. So I'm not trying to figure out what the recipe is, and that way I have it broken down by ingredient what the calories are. Okay. So and now I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9. So and this is 9 tables, and I could go on from here because I got cookbook, I could do publisher, I could do versions for recipes, I could add tons more stuff to this, right? So this is generally how you go about creating a database. You start with one table, and then you write all the columns you think that belong there into that table. And you start going through the columns and say, does this make sense? Is this what it's supposed to be? Is this make sense here? Okay. And then you go from there. So I'm going to end it here and call it a day. If you have any questions on the creation of the database, please let me know. If you're going to do this, and so if you are doing your final project, this is where you should be now. You should be designing the database. You should have your idea already. I haven't graded the week 3 stuff yet. I got to get that going, but I should have it done next day or two, and then go on from there. All right. Any questions? Please let me know. If not, I will talk to you next week. Thank you and goodbye.